In order to safely and efficiently troubleshoot, locate, and repair DC ground faults, it's essential that you understand the inverter topologies and DC system grounding configurations that you're going to come across out there in the field. Let's get started by simply introducing two key concepts: inverter topologies and DC GFDI. So what is an inverter topology? Topology refers to an inverter's electrical configuration and design, and from one topology to another, system grounding and protective devices vary. And when these things vary, it impacts inverter operation, troubleshooting processes, and our safety as technicians out there in the field doing the work. And a PV DC GFDI is a ground fault detector interrupter. GFDI attempts to make PV systems more safe by detecting ground faults and interrupting the flow of current. All inverters are going to have a listed DC GFDI as it's an NEC requirement, and it's typically going to be integrated into the inverter. GFDI functionality varies between inverters as it depends upon the inverter's topology and its age. To properly understand what DC GFDI is, we need to look at the requirements that apply to it in the NEC. The NEC has two main requirements for it. It says that it needs to control faulted PV system DC circuits by either automatically disconnecting current-carrying conductors of faulted circuits, or by automatically ceasing supply of power to the output circuits of the device fed by the faulted circuits and interrupting their ground reference. Regardless of how it controls faulted circuits, GFDI protection equipment must provide indication of a fault at a readily accessible location. Examples of how this is done include remote indicator lights, displays, monitors, or alarm systems, and notifications by web-based service.